Now we'll take a look at logarithms in a functional form. So we know that if we have an exponential function, we have the inverse is a logarithmic function. And if you recall, an inverse of a function is reflected across the diagonal y equals to x. And so you can see here in this particular graphic that we've given you, the red and the blue graph. And the blue graph is the logarithmic function. So I've also done another one on the calculator here. So we have 2 to the x, and then we have log base 2 to the x, and so you can see they both have the exact same base there. And then I went ahead and did y equals to x so you could see the diagonal. Now, a couple things to note. If we had the exponential function and the x-axis was the horizontal asymptote, as we take the inverse, the logarithm, the y-axis actually becomes a vertical asymptote. And then the same thing with the intercepts. If we see in the exponential function that the intercept was 0, 1, then now we're going to have an x-intercept of 1, 0. So you can see that based off of the calculator, we basically reverse or flip everything around as far as domain and range is concerned, intercepts, asymptotes, and things of that nature. So it's very important that you get a feel for how to sketch logarithmic functions. Now, just as we had with every other function, the base function is logarithm. Log base b of x is the parent function, and then of course we can put in our h's and our k's and an a value as well, and they have all the same properties that we had with other functions, with the stretching and compressing and the translations as well. So what I'd like you to go ahead and do is to just make an effort at sketching the following examples as best you can. If you need to t-chart a couple points, that's fine as well. Okay, if I look at sample problem number 5 here, if I were t-charting, for example, if I were going to do this with a basic t-chart, if you recall back that log base 3 of 1 was going to equal to 0, and log base 3 of 3 was going to equal to 1. These were two properties at the beginning of the notes in a concept box that I said were very important. And so you can see here that's a really quick way for us to get a couple points. So if x is 1 in this case, then y equals to 0, and if x is 3, then y equals to 1, and we could simply, and we know that the y-axis is going to act as a vertical asymptote, and that would be a quick sketch of that given logarithmic function. Now, in the one down below, we have some transformations going on. So the simplest thing to do may be to graph log base 4 of x before you even get started. And if you did that, simple t-chart again give us 1, 0, and 4, 1. Those are always really, really simple points that you can work with. And so your parent function is going to kind of look like that. Now, we know that this 3 right there is going to move us 3 to the right, and that 4 right there is going to move us up 4, because that's our h and our k. So if I went 1, 2, 3 to the right, 1, 2, 3, 4, I could move each point. And then also, with the fact that we're moving 3 to the right, we also have to move this vertical asymptote 3 to the right, and so we have a new vertical asymptote there. And so we would just simply sketch the same way we did the other one as best we could. That gives us a general sense of how to sketch logarithmic functions.